This is the recapitulation of the practices we did on this semester. In practice number 1, we cut aluminum bars to 2.5, 4, 5.5, and 6 centimeters, check errors with a caliper, and compare metric versus English with a micrometer. In practice 2, we build a frame with 150 millimeters U profiles and 13 millimeters angles during 32 holes and revert.
Practice 3. We made a sheet metal box by marking and cutting the layout, removing the corner squares, and bending the tabs to form the shape. We drill the holes, revert each corner, and sand the edges to give the piece a clean final finish. Practice 4. We hit a steel bar on the internal red hole and we work in an EA while using the Harman flatten a section and form a tip. This practice shows how metal softens with a heat and how important control, precise strikes are for a sharp.
In practice 5, we focus on cutting steel profiles. The process involves precisely measuring and marking the metal. The crucial step is to debure the edges with a file, ensuring the piece is clean and ready for accurate welding preparation. The sixth one covers small arc welding. First, we set up the machine and insert the correct electrode. Safely strike the arc and maintain constant travel speed and angle to create a solid weld bit. After cooling, we remove the slug and visually inspect the weld for proper fusion.
Practice 7. Micmac welding. We welded several T-joints and butt joints, noticing how the shielding gas produced a cleaner weld with less sputter than small. We brushed each finished bit to remove the thin layer of slag and check for porosity. Practice A. Sand casting process. This practice brought together everything we had learned: design, measurement, safety, and teamwork under pressure. The biggest lesson was that in casting every detail matters. It was the perfect culmination of our journey in the manufacturing lab. In conclusion, this practice cycle transformed our understanding of manufacturing. We went from being a team that only measured parts to being able to transform raw materials into the creation of assembled and functional products. We are confident that these fundamentals will be available in any future engineering project.